First of all, thank you for inviting me to share my thoughts with you here today. Really exciting presentations preceding me, and I think quite a lot crossover, so the panel should be interesting. I have two roles at Central St. Martin's. I've been in education for about 20 years now. I come from textiles originally, and I've always been exploring how could we reconcile ecology and textile design and textile fabrication. When I looked into this 25, 30 years ago, it wasn't popular. It was really actually an issue even to bring it up. We've gone a long way now, but I do think we really need to look at technology and new biotechnologies to help us make the next big step. So two roles, working with LVMH to push sustainability in a curriculum, because I think it's important that actually all the future generation of designers are eco-literate. Also collaborating with LVMH Maison. Nicholas Kirkwood was here, we're working with them. I can't talk about the projects now because we've got loads of projects across architecture, fashion, but they're not finished yet, so I can't talk about it. But what I will speak more about today is my role as a director of the Design and Living Systems Lab, which is really looking at exploring the interface of biology and design for future sustainability. So as a designer, you tend to think about the next line, the next collection, but it's very difficult to think about the bigger picture and, planet Earth. And how we are, and this is really interesting, we are the first species that is actually changing and impacting the geological forces of the planet. And if we look at, this is a sort of history from Paleolithic to where we are now, you can see that massive peak, which is really about this great acceleration. The dotted line you can see on the slides is 1950. And you can see from 1950, everything's gone up. Our water use, our population, our fertilizers, everything is going up. And I don't think you can be a designer today ignoring this. You can't be the same designer today as you were 10 years ago, 20 years ago. You have to build in that capacity to engage with these issues. And I won't go into sustainable lectures, but we know we have endangered elements. We're running out of some of the elements. We're actually completely relying. Probably some of what's in my computer, what's in your mobile phone is actually already we know we're going to have a shortage. We are responsible for the 6th extinction in terms of our biodiversity. I don't want to be attached to this as a designer. Yet my industry, textiles and fashion, is absolutely part of this trigger. A few facts, just purely in terms of numbers. From 1980, using 5.2 million tons of polyester to now, in 2014, 46 millions. It gives you an idea of the sort of, doubling our production of clothes. We're already above a safe level in terms of CO2 emission, but according to the Pulse report from last year, we're looking at increasing another 60% by 2030. We do need to urgently look at a real paradigm shift, and that might come from technology. A very positive framework for change with the UN SDGs being published. Some companies adhere to or not, but how do you design with them? And one of the things I want to talk about today is really how do you rethink design in the context of future fashion, future technologies, and future biology. The shift to the linear economy, from the linear to the circular economy, is a really good one, and I'll use that slide again, but I might be controversial. I'm a big supporter of the Ellen MacArthur Foundation. I think they're doing superb work, but I think this could be misread as well. This slide talks about looking at the biological nutrients on the left and the technological nutrients on the right. And the biological nutrients is working with what's renewable, what's alive, what we can grow, what we can regenerate. But on the right is the technical nutrients. It's what we're mining or what we're digging for, like oil, for instance, for polyester. And I think there's a risk that if we follow this, we will think that actually it's okay to carry on mining, but actually we need to move back to one planet lifestyle. I think we need to slowly phase out the notion that we should mine for more materials, more metal, more oil. Yes, we need to reuse what exists, what's out there, because it's there, it's out now. But I think we need to really move into looking at really what's happening with biological nutrients and how we could actually operate in terms of a fashion system that actually solely relies on biology. And biomimicry is what has been my interest for the past 15 years. How can we emulate natural systems which are cyclic, local, and solar, and how we can adopt this biological advantage and how we can integrate this in the way we make. I'll give you a very short example of what I mean by the biological advantage. If you look at how we build an iPhone, this is a list of metals, materials that we are using to build an iPhone. About 62 different types of metal go in an average mobile handset. 12 have no foreseeable possible replacement. So that's starting to, the notion of scarcity is becoming more present. If you look at a universal system, think of a tree and how a tree will make its leaves and its branches and its trunk. It's actually using very, very few elements. Locally, at ambient temperature. And I will show you one of my favorite organisms, diatoms. Diatoms are microalgae that actually live in the ocean. And this is a nanoscale photograph that shows the skeleton of a diatom. The diatom is actually bioengineered naturally to harvest traces of silica found in seawater, and has the right enzymes and proteins to turn these traces of silica into a glass-like skeleton. So the skeleton of diatoms are purely harvested from traces of silica in seawater. And you can see the precision engineering of this skeleton. It's extraordinary. There's loads of different kinds of diatoms. You can see loads of different types of shapes. And they create their skeletons using simply their ability to harvest traces of silica through biology. So I think there's a lot to learn from how nature makes, how nature biofabricates. This is how we make glass, a huge amount of energy, transporting sand and silica from across the globe, whereas the diatom will make it locally at ambient temperature using sun energy and water. So we think we're quite an intelligent, kind of superior species, but I quite like the way the diatoms does it. And I think we need to really become more humble and start to learn from what nature offers before we carry on destroying it. So the key questions for me as a design researcher is how do we move away from that take, make, and dispose modes of thinking towards much more biocircular modes of production? How can we biologize a design brief? And here I reference Janine Benyus, who wrote on biomimicry back in '97. How does nature make a textile? Because actually, nature makes a textile, and I'll show you. This is the bark of a coconut tree. It does look like a woven cloth. It's quite rigid, not necessarily the nicest in terms of touch. This one is absolutely fabulous. I've totally fallen in love with lace bark. This is from the Lagetta laghetto tree in Jamaica. That makes a bark that looks like that. So this looks like a fabric. Even the seam on the end looks like it could be a woven cloth, but actually it's made by a tree. Locally, ambient temperature, using the sun energy, bit of water, the tree knows how to make a textile. This is the Venus flower basket. The first time I saw one, I thought it was a weird 3D printed something. Actually, no, it's not. It's something that actually grows in at the bottom of the ocean, and which has at the base these sort of very fine fibers, which actually have superior qualities compared to our fiber optic qualities. So nature does best. That's another one of my favorite, a mushroom that makes lace. So I'm interested as a textile designer, this is my original training, to look at how we can shift our way of thinking and our way of designing and making towards the bioeconomy, looking at biomimicry and working with the organism industry that Amanda referred to earlier. The bioeconomy is something that we hear more and more about. Some countries have now developed strategies for bioeconomy, and in contrast to the petroleum-based economy, the bioeconomy relies on a production of renewable biological resources. But what is new is that it combines what we know as agriculture, and not necessarily sustainable agriculture, I have to say, because if you look at monoculture and you look at how we use pesticides and fertilizers, we have a lot to improve the bioeconomy. But one of the new dimensions of the bioeconomy is what's happening with biotech and genomic research, such as synthetic biology. And that's giving a whole new dimension to the bioeconomy. The EU argues that before 2100, we will have to double our output of raw materials, whilst at the same time halving our environmental impact. So we do really need to start thinking, how do we design differently, how do we make differently? And I think what is really exciting, and I'm not for or against synthetic biology, there's issues to do with ethics, which I want to discuss towards the end of the talk. But I think we're now in a position that we actually have the science, and it's beginning to be commercialized, to actually reprogram things like algae, yeast, and bacteria to produce tunable, bespoke materials for us. I think what's going on is really exciting. We're shifting from a mindset of a 20th century operating system where we heat, beat, and treat. And again, I reference Benioff here. The idea of you take material from the earth, you beat it, you treat it, you heat it, to make something with it, and you dispose it. The 20th century was really focused on chemistry and looking at how we can transform. You know, polyester is the main fiber used in the fashion industry still, but that comes from this chemical mindset. But also we had this mindset of thinking that nature is limitless. You know, if you look at textile manufacturing, historically, textile mills were placed next to a river because you can use the water for dyeing and treating, and you can reject the water untreated in the river. So there's a real connection to this idea that it doesn't matter, you know, Earth is big, we can actually use as much as we want, and we can toxify Earth as much as we want. But I think we're shifting slowly to a 21st century mode of thinking, which is much more looking at a biological revolution. Manufacturing becomes brewing. There's a focus on biology, and I think what is limitless now is technology, whether it's AI, whether it's synthetic biology. And that's something we need to get our mind around as designers, you know, because this is going to change our supply chain. My next supply chain will be a bacteria, will be a living factory. So how does that imply, what does that impact in terms of my design approach? So I set up the Design and Living Systems Lab back in 2013 now. When I set up the Masters of Textile Futures in 2000, it was the first course at Central St. Martin's that integrated sustainability in the assessment criteria, which at the time was quite a revolution. And one of the first things we did was to actually bring biology in a curriculum. So we collaborated with biologists that ran workshops so that we could understand the principles of life. How does a system, a living system, operates, biofabricates, survives, multiplies? What is the principle of self-assembly, which is magic still to me? And I looked at, in the early around 2010, working on another project I won't reference now, first heard about synthetic biology and started to think that's interesting. There's also a lot of designers now dissatisfied with the existing material matrix out there and actually creating their own materials, so the whole world of biodesign. And I curated the first exhibition that looked at biodesign from a sustainable lens, commissioned Suzanne Lee to create a shoe, which was the first shoe made by bacteria. This is Thomas Libertini making a vase with 60,000 bees. This is Ecologic Studio creating habitat for algae that will actually capture CO2, clean the air. And out of this exhibition, it felt for me that purely as a designer, we need to really rethink our methodology. How do you design when you work with all these different ways of working, from hacking nature to actually imitating nature? And I came up with this framework, and I will show you 3 examples related to this framework. Nature as a model, so it's when you're inspired by a model found in nature and you try and emulate it. Nature as a co-worker, so it's when you work with a living organism, such as fungi, like mycelium is made with a living system. Or hacking nature, which is synthetic biology. So nature as a model, and here I'll show an extraordinary piece of work done by Dr. Jane Scott, who did a PhD with us, completed 2 years ago. She's an academic, she's a lecturer at Leeds University in the UK. And she looked at the pine cone and how the pine cone opens and closes with heat and humidity. That's what happens naturally. And she created an incredible series of cloths, which are the first 100%, is that working? You can see how it's moving. This is the first 100% natural, programmable, smart textiles. This is 100% silk and linen. It's simply in the way it's knitted that it's actually responding to an increase in humidity in the environment. And what she managed to do was to create a whole range of different, so this one actually peaks, but she's managed to knit some that actually will sort of curve one way or curve the other way. So this is absolutely, this one is 100% linen. So it's a smart textiles that doesn't use polymers, that doesn't use electricity, that doesn't use any metal for conductivity. This comes out of really thorough researching and understanding biomimicry and how a pine cone works. Nature as a co-worker, so how do you design when you collaborate with a living organism? And I'll show you one of my projects, which is mycelium textiles, which I started back in 2015. I do loads of different things, so this project is still ongoing, but it's when I have a minute, literally. But my idea was to look at, could we use mycelium techniques to actually revisit traditional textile techniques, such as mending, coating, patterning, texturizing, dyeing. what is interesting as a designer is that normally we train to work with inert, dead materials. So if you work with cotton, it's not living anymore, it's live. So you know how to manipulate it, transform it. But when you work with fungi, mycelium, you have to create the right parameters. It has to be at the right temperature. It has to be the right humidity level. And depending on what you feed it, you get a different material. And this is really exciting as a designer. So I will speed up, but this is, for instance, looking at can we replace the puff binder or what we call the expantex, which is a coating, which is polymer-based normally. And so can we create this effect through using mycelium? This is creating a mycelium lace, permanent fold. So this is, again, produced at ambient temperature locally. And that fold, I should have videoed it, but you can stretch it, it comes back. It's a permanent fold. The most extraordinary for me was actually this one, because this was a mistake. And this is the other thing, is, I work very much as a scientist. Whenever I do that, I set up experiments, I record my experiments, and I see what happens. This one I thought was a failure. This one is 100% coffee. I work with local coffee waste from all the coffee shops around the college and in the college. And normally you mix your mycelium with its food substrates and you put it in a mold. But that's not what I did here. I actually compacted some coffee, and that's why you can see the round shape. And I then inserted mycelium into it. And I let it grow for about 3 weeks. I thought it had failed because the surface was still covered in coffee, but I could see some white on the edge. So I thought, okay, well, it's grown, not sure what's happened, but I need to, close that experiment. So although I do collaborate with that living organism, I have to say I also have to kill my worker. So to get the material, I have to bake it. So I baked it, and it was still covered in coffee, and then I thought, okay, I'll just wash it. And then I discovered those flowers. These flowers have grown on the surface of the material. And if you look closely, they look fractal. You can see that on the left-hand side, it looks quite closed. On the right-hand side, it's quite open. You can still see the stain from the coffee. So what is quite spooky for me is that as a textile designer, I remember when I trained, I hated having to do floral design. And you do have to learn floral design when you're a textile designer. And this mycelium in my back is making flowers. And I don't know how this happened. I've tried to reproduce this twice now. It hasn't worked, so I'm still trying. But this really is what's exciting, is, when you co-work with a living organism, there's a feedback, there's a bounce back. It has living properties, it has self-assembly properties. And so the issue of control becomes really interesting. How do you design with self-replicating dynamic living properties? We have historically known how to control this. If you're a baker, if you make wine, or if you make cheese, you know how to control your yeast. But I think this is really new. This is becoming part of what is the craft of a designer, working with living systems. And what is exciting is that it's not just an experiment. There's a whole array of designers that actually are working with mycelium now. And the latest kid on the block is Ball Thread, that has now launched Milo, mycelium leather materials. Mogu is recent as well. Phil Ross, I should credit here. Phil was an artist who actually initiated really this research and influenced a lot of us. And I'll conclude with hacking natural systems. So how do we actually get into reprogramming living systems and reinventing nature? And the original really kind of big hype was in 2010 when Craig Venter declared having created the first cell, the first organism created on a computer, which is nicknamed Cynthia. So this was the origin of the sort of practical synthetic biology. And this happens because we can now print and code DNA, and we can boot it up in a living cell. And in 2010, I was looking at these technologies thinking, well, what does that mean for textiles? And this is pre-Ball Thread, pre-everybody else. And I was thinking, could that be the answer for future manufacturing for textiles? We know that in nature, there is a DNA or a set of DNA codes that make fabric-like materials. So I looked at, could we combine the sort of the ones and zeros of our binary world with DNAs to create things like a future hydroponic greenhouse system where we can grow food and fabric at the same time. And so this strawberry lace, this is fake, this is not real. But the idea was to put out there the imaginary of this technology to try and revisit how that could benefit our present. So this was looking at, so basil numero 5 was growing a perfumed lace and a culinary herb. At the time, in 2010, biologists were telling me, no, 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 synthetic biology, we're going into energy, we're going into medicine, we're not going into textiles. And actually, it's all happening in textiles now. We've seen modern meadow, I won't talk about it, but what's interesting is this notion of a yeast reprogram to produce collagen, which means we can now have a liquid material, so we can treat leather very differently. These are examples of modern meadow. What is also exciting for us is at St. Martin's, because we've integrated biology in a curriculum for quite a while. We have, so for instance, Amy Camden is now the design team leader at Modern Meadow. She's also finishing a PhD with us. So we're training designers to have that biology language, to be able to collaborate with these biotech companies. The idea of brewing as opposed to manufacturing brings an interesting dimension to the notion of locality. There's a real trend towards, loads of cities now have their brewed beers. You've got, loads of beer brewery in London, beer brewery in Stockholm. Could we now look at why can we just have the London silk brewed? Or, could we actually start looking at bringing back manufacturing closer to urban centers where the material is needed? But what is interesting is that this birth of this organism industry and the synthetic age will change the way we design and conceive for future fashion and textiles. Again, 20th century, I think the raw materials are found, they're harvested, they're mined. I think with synthetic biology, we can look at bioengineering and growing circular model of productions where brands can secure bespoke and unique genetic supply chains. We're moving from the handmade, the man-made, to what I call the grow-made. What this means is really looking at designing tunable and bespoke raw materials, potentially bypassing the chemical processes we need to treat fibers, watermarking and branding at genetic level. We can go into perfume and fragrance because synthetic biology is making vanilla, saffron, squalene, which is used in perfume. Creating a whole new set of living factories. But also what is interesting is we can program organisms to decontaminate and bioremediate. We can go into the extensions, we won't have time today. This means there's a real blurring of what is natural, because actually if you look again at the bold thread silk, yes, the organism that produced it is genetically engineered, but the actual silk protein is natural. And you harvest it and you kill the yeast. What you've got is an inert kind of dead silk produced by synthetically engineered yeast. What is natural in this context? What is interesting as well is to look at, can we think about, will this synthetic nature replace natural nature? What will be the impact in terms of sustainability at global scale? Particularly because yeast feeds on sugar. So we need to produce sugar to feed this technology. So there's a whole kind of consequence there. But I think whatever we do in terms of technology, we still have to think about the mindset of consumption. Can we consume better, not more? Can we look at actually really designing with natural living systems for a bioeconomy that can succeed if we alter our consumption behavior, fundamentally rethink the notion of progress to create a bio-materiality that is inclusive, interconnected, and mindful? And I'll stop here. Thank you very much.